Yeah, okay. All right, welcome everybody to the final day of the SMS. Next up we have Jerome Romagosa from UC Davis with Decentering the Everett interpretation.
Everybody, thanks for coming. So, a brief kind of overview on this talk. I'll do a little bit of background on the Everett approach to getting worlds, in case some of you aren't familiar. Then I'll turn to the Decentering Everett interpretation as presented by Isaac Wilhelm in his 2022 and 2023 papers. And its three components: the worm view, the centered worm rule, and the best systems analysis of centered chance. After that, my goal here is to kind of give three arguments pushing a bit back against this new approach to centered Everett interpretation. It has some merits. I think there's some things that need to be addressed or improved. We're going to course a view like this, and particularly the objections or arguments I raise against the view come from, I think, a vaguely Everettian perspective. So I try to show that if you already have reason to endorse the Everett interpretation, you might not want to endorse this centered Everett version. So a little bit of background on EQM, Everettian quantum mechanics, or the many worlds interpretation. So it's a no-collapse version of quantum theory, right? So rather than collapse, you have superpositions continuing to evolve, or your Schrodinger's equation deterministically, unitarily. But decoherence takes place such that you have semi-classical worlds or branches. So here, when the function evolves, you have a particle reflecting into the x upward direction for measurement of an event. And then the measuring device registering particles deflecting upward, and a person observing measuring device registering upward, and so on. And then in this other term of the superposition, you have a whole other kind of semi-classically isolated world with the downward deflection, the device measuring downward, person witnessing downward, and so on. So importantly, EQM says the fundamental dynamics of the universe are deterministic. It's not a probabilistic model with most. The universe just evolves according to Schrodinger's equation. So one natural question is to ask what the probabilities that the Born rule describes really are, given that everything happens kind of on, every outcome obtains in some branch. So one popular approach is kind of rationalist decision theoretic approach, developed by David Deutsch, but developed further by Greaves, David Wallace, others, says that the probabilities are something like rational credences. The Born rule is a kind of rational tool for how we should maybe bet or think about credences in our lives. So, in kind of alternative to that, more recently, Isaac Wilhelm developed this centered Everett approach, which says probabilities are centered chances. Whereas centered chance is a truly objective chance that some kind of centered proposition occurs. Whereas centered proposition is something like, I will find myself in the X bin of branch. Here, importantly, something we'll talk about is that the Born rule and then the resulting centered Born rule is supposed to be an objective and fundamental physical law. And then also that the centered Everett interpretation as a whole is supposed to provide helpful constraints on the normative principles that can kind of underpin the rationality-based accounts. So the objective chances in Isaac's view are supposed to somehow explain why we have rational reasons to bet a certain way according to the rationalist approaches. All right, so I'll turn to the details of this view real quick before moving to my arguments against it. There's three components: worm view, the centered Born rule, and the best systems analysis of centered chance. Starting with the worm view, many of you were at Prey's talk yesterday, day before? Day before. Or if you've seen versions of this talk before, you're probably familiar with the worm view, Curvature model, some people call it. So this takes objects to be both three-dimensionally, spatially extended, but also four-dimensionally, or temporally extended as well, so four-dimensionally. So for instance, you think about like a person walking across a room. Well, not only are they extended in the spatial XYZ axes, but the person's kind of an elongated space-time worm over time. They have different temporal parts at different times. So on the Everett picture, kind of the same thing. The worm view here, though, just a worm is along an entire Everettian branch or world, rather than just occupying this space-time. So Everettian branches on Isaac's view going to be branches of the wave function that behave like semi-classical worlds, and these two are these space-time worms. So both the branches are worms and the things in them, the persons, hats, cats, so so on are going to be these temporally extended things. Importantly, on the CEI description, branches are not created or destroyed by branching. So this is going to be a divergence view rather than one in which genuine fission occurs. It's not super important for most of my description here, but fun stuff to talk about if you want. And then just distinct worms don't share technical parts. Again, they're just exact physical duplicates at some time. So again, it means there's not really like two separate, when branching occurs, it's not that like one space-time worm becomes two. It's that the two always existed and their issues just start to diverge for a certain point of time. Okay, so second component is the centered Born rule, which states that the Born rule probabilities are objective chances of centered propositions occurring. Such like, I will observe the particle deflect upward when it is measured along its x-axis, or I'm the one in the upward deflection branch. And so, kind of formal representation of the centered Born rule is here. It says that the centered chance for an observer or agent E, given the wave function prior to some kind of measurement event, and then over this kind of centered proposition, like I'm the one in this branch, the centered chance that proposition obtains is equal to the Born rule probabilities of the wave function. So, some weird things will happen here. One thing to note is that, well, we'll talk about it on the next step. So, the centered chances here are going to be given by this chance function, but what is going to define what a centered chance is on Isaac's account comes from the best systems analysis. So we'll talk about that right now. So he uses David Lewis's best system analysis, where laws are the theorems of those deductive systems that best balance theoretical virtues like simplicity, strength, and fit. And these give the best description of something like Cuny and Mosaic, little ladders of facts based on. So on the centered Everett interpretation, what defines the centered chances themselves isn't the centered Born rule, but rather experimental frequencies within a given branch. So you can imagine some branch where a bunch of decoherence events have occurred, and people have done a bunch of measurements, and let's say they just do the same kind of experiment every time, measuring the x direction spin of a particle that was formerly in a z position, or sorry, z-axis eigenstate. And so you can think that each time this occurs, you get either an upward or downward deflection, and the relative frequencies of upward and downward deflections is what's giving you the actual chances in that branch. So here, the chance that I observe the outcome A, for some experiment X in my branch B, is given by just a summary of the relative frequencies of A outcomes for that experiment in that branch. So then, yeah, importantly, this is going to come with the consequence that the centered Born rule is not going to be a law on all of the branches. This is because the centered Born rule will best capture the centered facts about the relative frequencies on some branches, but not on others. On some branches, the experimental outcomes are going to match the Born probabilities, and some aren't going to be. So, you can imagine there's going to be some branches where the actual experimental frequencies deviate pretty strongly from the Born rule. We have like the extreme example that I have in a different paper, just every time somebody does the experiment, they get the same outcome. But you'll have plenty of other things that just are standard deviation or set away from the Born rule probabilities. All right. Let's now turn to the three counter-arguments against the centered Everett interpretation. So, first one is that something about this centered Everett interpretation strikes me as undermining some of the initial motivations for adopting tiny worlds. In that it brings back something about agent relativity, something like the measurement problem into Everett. So, which is, one of the reasons for adopting the Everett interpretation in the first place is to get measurement, the observer, out of fundamental physics. So one version of the measurement problem is that imprecise terms like measurement, observer should play no fundamental role in physical theory. Reasons like what constitutes measurement, is observer dependent, consciousness dependent. The whole point of Everett is something like we don't need agents or particular observers, we just need kind of physical interactions and decoherence in systems. So why should something like this be the source of collapse in standard quantum mechanics? And instead, people adopt realist interpretations like EQM, where we don't want to assign special significance to anything like measurement observers. This goes back to long before John Stuart Mill, but I think, this summarizes that. So, kind of point here is that realist interpretations like the Everett approach come at a cost. We avoid assigning any fundamental significance to important things like measurement or observers by taking it that superpositions just don't collapse, and that you have the emergence of a lot of semi-classically isolated branches, many outcomes, and so on. And that doesn't really fit with our intuitive understanding of the world. There's worries about ontological growth, whole probability puzzle, how to make sense of uncertainty, surprise, etc. And so there's this question of why we should adopt a lot of these potential worries about, very large, unintuitive universe, if we're just going to have fundamental laws concerning agents. And again, looking at the centered Born rule, it says that the centered chance of some agent has some centered proposition come out true. So the centered Born rule here is supposed to be a fundamental physical law, again, about these centered facts. So why accept these costs if we're happy to allow fundamental agent relativity back into quantum mechanics, but we endorse some other non-realistic approach or something more agential if you're happy to do so? Why go the Everett route? Well, kind of quick caveat here. So other versions of Everett, of course, take reference things like people in it, but importantly, on more orthodox writing approaches, neither the branches nor the Born rule have any fundamental physical significance. It's fundamental as something like the quantum state wave function, and the branches are ontologically derivative. The Born rule is the rational tool. So we're able to kind of maybe talk about these agent-related things, but ultimately reduce them or explain them in terms of the chance is regarded as epistemic, reduced self-locating uncertainty, or other kinds of views, the more orthodox approach. Now, I think Wilhelm does have the responses, some response to this kind of concern, this kind of argument. So he suggests that we can relativize the chance function in centered Born rule to branches rather than agents themselves. Here's a quote. He says, I stipulated that E is an individual, but E could be an entire world instead. So the chance function invoked in the centered Born rule can be relativized to either individuals or worlds. So we recall centered Born rule, and then just kind of revise it to say, well, the centered chance is a centered chance function for a branch that some centered proposition is true given the quantum state. Now, my worry here is that if we just plug in branch instead of something in a branch or an observer within a branch, it's unclear why the frequencies are going to come out as chances on this account. So if we think about kind of deterministic evolution according to Schrödinger's equation, we just have a bunch of branches as the result of the evolution of the wave function. There's not really the same sense in asking why a particular branch has the outcome in it that it does when we think that all of them kind of obtain, right? It seems like in order to get this chanciness off the ground, for these kind of relative frequencies to be chancy in a relevant sense, you need something that experiences them as chancy, which I think is why Isaac worked with the agential language in the first place, like to get the kind of chanciness due to something like maybe self-locating uncertainty. It's unclear why that's the case if we're just looking at this kind of emergent structure holistically. So now I'll turn to the second argument, which concerns the fundamentality of branch relative laws. Again, on the centered Everett interpretation, the centered Born rule and other branch relative laws like it are regarded as fundamental physical laws. So here I introduce two candidate notions of fundamentality, ontologically fundamental and explanatorily fundamental for laws, and show that centered Born rule and its analogies in unlucky or atypical branches satisfy neither of these. So first, just definition I came up with, ontological fundamentality. L is an ontologically fundamental law if and only if L is a law describing regularities concerning ontologically or fundamental or irreducible entities. So an example of what that might look like you take like a wave function realist perspective, like listen A, or David Albert, the fundamental ontology of the world is going to be a wave function in a higher dimensional configuration space. And so a fundamental law in that sort of world is going to be Schrodinger's equation, which describes the evolution of the wave function. So that would be an ontologically fundamental law. It's a law describing behavior of an ontologically fundamental entity. But now turning to the centered Everett interpretation, the law here at the centered Born rule is the law about behavior of a particular branch, the agents in that branch, the branches and the things in them are regarded as emergent phenomena rather than part of the fundamental architecture of the world on the Everett approach. You can see in the Wallace and others here. So laws about agents, and the branches aren't going to be ontologically fundamental. Perhaps they're explanatorily. So, other notion, L is explanatorily fundamental if and only if L cannot be explained in terms of more general principles, laws, etc. But if we look at centered Born rule, we have basically the Born rule on one side, and then there's a chance function, the relationship between them, that of identity. So the Born rule itself is something many Everettians take to be derivative rather than fundamental. In fact, I think that's like the most important things for the Everett interpretation to do is to make sense of Born rule probabilities and derive it from other principles. So we could look to Deutsch, Zurich, Sevens and Carroll, etc. for attempts to do so. Moreover, even if you don't quite buy that, I think there's this further concern where the in-branch macroscopic states that are described here are going to be emergent features of the holistic quantum state, and macroscopic experimental outcomes, those that form the basis for the centered propositions, can be explained in terms of the holistic evolution of the quantum state. So like the reason why it seems like prior to a branching event, I might have a 50-50% chance of observing myself in the X upward deflection branch and a 50 chance of observing myself in the X downward deflection branch has something to do with what's going on with the entire wave function rather than what's just going on within my particular branch. In order to get the branch-like structure, we have to kind of look, I think like in my case horizontally for Ray's presentation the other day, we flip things, but yeah, look at the entire branching kind of structure rather than just what's going on in the same branch. The in-branch facts don't provide an explanation of what will happen next in the branch, since the Everettian dynamics are set by the quantum state's evolution from the Schrödinger solution. It's not like the outcomes in my particular branch determine future outcomes in that branch. So, last argument concerns the accessibility and utility of the Born rule. So, by way of the best systems account of lawhood, again, the centered Born rule is true, it's supposed to be branch relative. The centered Born rule does not give the right chances for all branches, as we've discussed. This is because the mod squared amplitudes of wave functions are what gives the Born rule probabilities. The centered chances are determined by the in-branch outcome characteristics. So in some branches, the in-branch frequencies are not going to be identical to the centered Born rule, to the Born rule probabilities in the way that the centered Born rule explains. And so again, we can turn to this kind of unlucky or atypical branch case. So, with this in mind, we can think about how future outcomes in one's branch can't be known by an agent, even with perfect knowledge of the quantum state, due to, for instance, floating uncertainty. We just don't know what branch we inhabit. So, in terms of like thinking, I don't know what the future outcomes in my particular branch would be. But the frequencies across an entire branch are what set the laws via the best systems analysis of centered chance. In other words, they set whether or not the Born rule obtains in my branch. So for some space-time worms or agents that are temporally extended like me, that might be exact physical duplicates from any time t1 to t2. The centered Born rule could be true for some of those worms and false for others. In other words, if this kind of fission picture is right, where there's a plurality of entities just like me, up until the present, we could all do a bunch of experiments and have the same outcomes from T1 to T2, but going forward into the future, some of those worms are going to have born non-conforming results in the future, some will have born conforming results, and there's nothing between T1 and T2 that gives us any evidence to be able to pick out, like, oh, I'm going to be in one of the lucky branches, or I'm going to be in one of the unlucky ones. So the centered Everett interpretation is likely going to entail that the evidence available to an agent during any kind of temporal interval is insufficient to determine whether the centered Born rule gives the right probabilities for one's branch, and hence whether the centered Born rule is actually true or false in that branch. So we can't really know what laws hold in our branch. Now, this might just be a general problem of induction, but I think it's interesting to think about in this particular context for a number of kind of examples that I'll bring about. So one of these is that according to the centered Everett interpretation as presented by Isaac, we're supposed to be able to not have to posit any principles of rationality in the CEI, and that these branch relative laws are able to somehow underpin, explain the rationalist kind of approaches for why it might be rational to believe that you're in one branch rather than another. But given these issues with self-locating uncertainty and the fact that no evidence is sufficient to determine what branch one is in and whether or not certain laws like the centered Born rule will obtain in that branch, I don't think that the centered Everett interpretation can kind of do the work that Isaac says that it will do. I don't think it can constrain rationality in any way that doesn't already kind of presuppose something like a rationality-based account. So we'll look at two cases. First one is the apparently unlucky case. So an agent worm W observes thousands of C-spin outcomes in a row after setting up experiments to measure the C-spins of particles or X-spin eigenstates. So here, we think that the worm W is still maybe more likely, in some sense, to live in a branch in which the total frequencies are ultimately going to match the Born rule frequencies than otherwise, so long as the proportion of experiments that would be performed in the future is sufficiently greater than those that have already been performed. So, you think about flip a coin 1,000 times in a row and it's always heads, well, the chances that your future coin flips start to converge 50-50, it's going to, that's going to be much more likely in some sense. And we think, according to something like the Everett picture, well, the weight of branches that are Born conforming going forward, even given these initial weird starting conditions, are still going to have a much greater weight than those that continue to be, radically atypical. So that's kind of the apparently unlucky case. Like, someone's evidence so far suggests that they live in something like an unlucky branch where the centered Born rule doesn't hold, and yet, if the Everett picture is right, their luck is probably going to turn around. You're more likely to be one of the kind of generally lucky worms going forward. On the flip side, we have the apparently lucky case. So the worm W observes Born matching outcome distributions from time T1 to T2. W takes it that the centered Born rule must be true in their branch, and then predicts that future outcome distributions will follow the trend of matching the Born rule probabilities. Seems pretty reasonable. So I see, it looks like the Born rule is true. That's probably going to hold in my branch. Well, conditional on the truth of the Everett interpretation, for most of the worms in W's position, that will turn out to be the case. And frequencies observed from T2 onward are going to continue to align with the Born rule. But the fact that the frequencies in the future continue to follow the Born rule doesn't really have anything to do with the previous frequencies obtained on that branch, right? It has everything to do with how the wave function is going to continue to evolve in the future. So it's not like these previous frequencies are doing any kind of explanatory work for the future outcomes in the way that I think branch relative lawhood should do. We need to appeal to more general kind of global facts rather than these in-branch frequencies in order to explain why future outcomes from T2 onward are going to continue to be like those from T1 to T2. So in both the apparently unlucky and apparently lucky case, there's going to be facts about what it is rational for subjects to believe. But in neither case is it clear to me how the centered Everett interpretation specifically provides grounds for these facts. The laws here derived from experimental frequencies across the whole branch are the kinds of things that are inaccessible to subjects. If I want to use these frequencies to make further predictions, I need to know what branch I'm on, but in fact, I don't. The outcomes actually observed within a branch or some past temporal interval aren't going to determine future outcomes in that branch, and the universal function does. So, what a subject's rational credences should be has nothing to do with whether or not the centered orbital is true or false in that branch, but rather hinges on the evidence available to the subjects in that branch, which again doesn't determine whether or not the law is actually true or false in the branch. It's just what is rational based on previous evidence. So, kind of to wrap up, now provided three kind of arguments pushing back against the centered Everett interpretation on broadly Everettian grounds. Part of my kind of point here is that I think we already have reasons to maybe be skeptical of bringing a fundamentally agential back into Everett interpretation. But even if we think that the centered Everett interpretation can proceed without undermining these initial motivations for adopting Everett, then we still have reason to think that the new laws described by the centered Everett interpretation, laws like the centered orbital, that are branch relative, aren't fundamental. So that's what I kind of showed in argument 2. And then moreover, even if one grants that there are such laws, it's still unclear to me how we can know these laws, when they hold, and how we can use them to constrain one's reasoning or make predictions about the future in a way that could help to ground rationality-based accounts. It already presupposes something like making induction based on evidence. That's what's doing the rational work here, not thinking about the truth or falsity of these branch relative laws. So, thank you all.
And now we have some comments from
Sorry, unlike some other more diligent commenters, I don't have slides or handouts. All right, so first I'd just like to thank Jerome for a very cogent paper on a topic I think is important and under-discussed. In some quarters, like Dr. Tim Maudlin, it seems like Wallace 2012 kind of ended the important developments to Everettianism, and I think that's just obviously wrong. So I'm glad Jerome, Ray, and this conference are pushing us forward. So, in my brief kind of response, I'd like to make 4 points. First, one about the worm view, which undergirds both the Wallace view that Jerome is defending and the Wilhelm view that he's attacking. And then one brief response on each of Jerome's 3 objections to the CEI, which are not obviously comprehensive. Okay, so first, a little on the worm view. So the worm view, right, is that the branches or worlds of Everett are real, concrete 4D worlds of macro entities, that unlike in Everett's own account, these diverge rather than overlapping or fissioning. Since many branches share a history up to a certain measurement, the question of which result in the measurement I will see depends on which of those branches with identical macro history up to this point is mine. In Wallace's 2012 account, these branches emerge when decoherence semi-classically causally isolates regions of the quantum state. Branches are therefore dependent on the interests of agents because semi-classical isolation is interest relative. For agents who care a lot about the details, the bar for classicality is high. They're going to notice anomalies. And a few worlds are sufficiently isolated. For agents who care a little about the details, the bar for quantum behavior is high, and many more worlds are sufficiently isolated. So basically, we often just picture the dendritic structure, as branching like this, right? But if I've got 5 branches here at a certain grain, at a coarser grain, I might only have 3 branches, and those branches are actually going to diverge a little bit later, right? Because we're coarser grain, what we observe as meaningfully different behavior will happen only later on in the history. I think this creates some problems for the way that Jerome discusses these cases too. So for instance, the identity conditions won't be symmetrical. So Jerome's thinking about Sally here and Sally here, right? And what differs those. But think about Sally here versus Sally down in the coarser branch. So Sally big picture, who's in the coarser branch, thinks she's the same as Sally detail oriented, because that's they only differ in some minor way that's not relevant to her. But Sally detail oriented thinks Sally big picture is a counterpart in other worlds. So which is it? Do these worlds diverge or not? I think that's left unclear in this picture. Also, second, an implication of this that concerns me is how can agents be the cause of their own emergence? So worlds don't emerge apparently until agents decide they're semi-classical, because there's no threshold at which semi-classical is now a thing. But without semi-classical worlds, there can be no special sciences governing the evolution of agents. Those all seem to happen within worlds, right? Those are Yeah, those aren't quantum, right? We don't have quantum evolution theory. So this loads up the questions that Jerome wants to ask about whether laws are fundamental, whether laws of special sciences are fundamental, or branch relative laws are fundamental, and whether there could be objective chances in non-fundamental laws, per Wilhelm, since all non-fundamentality seems to be kind of subjective in some way, post-emergence, and emergence itself depending on what we decide the grain is. So these concerns aren't original to Jerome's paper, but I do worry that they muddle the debate a little bit. But moving on to the first of Jerome's worries about the centered Everett interpretation itself, the question of undermining Everettian motivations. Particularly, I want to focus on Jerome's argument that centered Everett interpretation is unduly agentic, because centered chances have to be relative to agents, and branch relative chances, on the other hand, are meaningless. Here, I think Jerome's argument is sound as stated, and I think Isaac might have been a little less careful than I would have folked with the language there. But day-to-day questions of chance don't have to be formulated with regard to agents or to branches. Just ask, will this device, this whole Sturgeon-Rolack experiment detector here, measure X spin up or X spin down after I run the experiment? So in the worm view, right, branches don't overlap. They're four-dimensional, evolution is deterministic, so there is some fact of the matter, what will this detector measure, and no chance. Yet, because the X spin up and X spin down worlds with identical prior histories have not yet diverged, right, or pre-measurement, this device, the indexical, is ambiguous between the two. Is it the world that will be X spin up or the world that will be X spin down? And at the fundamental level, there are no yet isolated regions of the quantum state, right? So, you know, here at the derived level we have two things, but they look the same, and at the fundamental level we just have one thing. So so by the divergence metaphysics, they're different devices, right? They're both 4D, the one device will measure this later, the other device will measure that later. So they're different devices, and so there's a problem of centered chance, right? Which world are we in? But if you deny that there are centered chances within worlds, then it seems like worlds just evolve superdeterministically. We don't have any way of identifying chance kind of within the world, and agents within such worlds might as well just believe in superdeterminism rather than quantum mechanics of any flavor, right? You just, fundamentally, all your experiments are correlated because they all happen within this world. So you need some kind of within world chance. And I don't think here we have anything particularly agentic. We just have to point at indexicals like this device, and those are indeterminate between worlds, unlike the branch, which refers to the worm by definition. This is ambiguous because of the history, and yet we're not talking about an agent, we're just talking about a device, which it seems like we should be able to do in physics without being kind of unduly agentic. All right, so this brings me to Jerome's second objection about whether such branch relative laws about centered chances should count as fundamental. The straightforward answer is that they are explanatorily fundamental, because the uncentered laws cannot explain the chance of what this device will measure, because they can't refer to it. So if I want to have a law that says there's a 50% chance that this device will measure X up, 50% down, I can't speak about that in an uncentered way, because the uncentered system can't refer to this device. It can only refer to what's at the fundamental level. Nor can they refer to any unique supervening space of the device, to which talk of it can be paraphrased, since this device and its counterpart are not yet distinguished at the fundamental level prior to divergence. There's no decoherence yet. So if we want to have a science which tells us about the probabilities of what will happen to this device, which seems like it's fundamental to kind of building quantum mechanics, then we're going to need some kind of branch relative laws. And then last, if laws about centered chances can be fundamental, can they be accessed? Jerome says no, because we can always be in an unlucky branch where the centered Born rule isn't true. But as Jerome kind of admits, this is a little bit true of all kind of inductive cases, certainly of all Humean law, right? So Newton's law of gravitation could look like the best system for a long, long time in the mosaic, and then at some point it wildly fails. And nor is the problem limited to Humean accounts of laws. So induction can fail for any contingent law, right? It can govern the world, and then something else governs the world, or whatever. So the only way it seems like to really avoid this problem of accessibility that Jerome brings up is to take the Al Wilson view that the laws of quantum mechanics are metaphysically necessary, which the centered Born rule obviously is not. But I think that just leads to a new problem. No experiment can then, seems like, confirm the laws of quantum mechanics, because the laws where the results hold aren't drawn from distribution. So it'd be like treating you got this result in a math problem and you got this result in a math problem as somehow being the distribution or something like that we're supposed to do statistics on, rather than just saying like, oh, it's metaphysically necessary what the right answer is, and we're just kind of gathering a little bit of, so it seems like this makes physics into a kind of like math or something. So if any meaningfully physical laws are accessible, I don't see why the centered Born rule shouldn't be. All right, so the conclusion I think is just that Everettians need to think more seriously about how emergence and contingency work in their theory. There are big literatures on these topics, and they can't do the needed work for Everettians in the cavalier way that I think Everettians, and sometimes Wallace particularly, uses them. So I think Jerome's done us all a favor by drawing more attention to these kind of internecine disputes within Everettianism and forcing clarifications to Isaac's language around fundamentality and world centering. So thanks, Jerome.
Response from Jerome?
Thanks a lot, Ryan. It's given me a lot to think about, and so for some of the points, I'm just going to go ahead and say, largely in agreement with you. For some others, it would be helpful if I could get a little bit more clarification, and then I've got a bit of responses. So starting with the problems with the worldview, I think as of now, I'm largely in agreement, right, with there's this issue of grain. When looking at the worldview, particularly on these, I think the divergence picture has problems with grain, as well as maybe even the fission pictures as well, for when branching actually occurs. And so setting the kind of reference for what counts as a given agent is something that is underspecified, even at that level. And there are these interesting questions about whether or not you can, of course, grain agent will agree with a fine-grained agent about whether or not they are identical. And that's, I really don't have a great response here. I kind of presupposed the worldview, since that's what Isaac was working with here. And that's a topic that I'm actively working on, is trying to figure out identity conditions, persistence conditions in Everett. But yeah, that's something I'm still working on. So thank you for bringing that up. I do agree that it's a problem. Next, for interpreting branch-centered chances, we focused on the kind of first argument that I brought up involving the agential nature. So you point out that terms like this device are going to be ambiguous between statements, and that the fact that our reference here of something like this device is going to give rise to something like centered chances, even in the absence of the agential component. Like, that's kind of the essence, right? Yeah, so I guess I'm not yet. I understand the problem with reference here, securing reference on any kind of either fission or divergence view, where there's something like branching or coherence. I'm standing here. Well, there's a plurality of things standing here right now, right? And I say, I'm standing right here. Well, which thing am I referring to? All of them. If I say Jerome's going to get Vietnamese food after lunch, which Jerome am I referring to? So I do think there's a problem with reference here. I'm just not sure, without the kind of agential component, how that particular issue with reference gives rise to chanciness, rather than just difficulty in kind of securing reference with my language. So I do think when it comes to agents, you have this subjective self-locating uncertainty where you're capable of kind of asking the question. But when it's just kind of ambiguous which device I'm referring to, I'm still a little bit unclear where that change arises. So I would love to get a little bit more explanation there. This kind of carries over a bit into the fundamentality question. So you say that the straightforward answer to whether or not rank relative laws could count as fundamental is that they are explanatorily fundamental, because uncentered laws cannot explain the chance of what this device will measure, since they simply cannot refer to this device. Again, I think the uncentered laws do explain what all of the devices will measure in each branch, but yeah, it seems again like a problem of reference to me, rather than a problem of genuine chance or any kind of emergent law here. But yeah, this is it's something I do need to think more about. I'm just a little bit unclear about how the failure to reference gives rise to new law here, rather than just a fundamental issue with reference that even the centered Everett interpretation isn't able to give us. It's not like the centered chances secure reference in the way we want either. It's still impossible to refer to this device or that device in a centered way on this interpretation. So yeah, I grant that something's still weird. I'm just not exactly sure how to solve it, or how taking the law to be fundamental gives us any further explanation. Lastly, I guess for the accessibility question, yeah, I do think ordinary problems of induction arise here. Part of my point for bringing up the accessibility and utility of the centered Born rule is that while in other contexts, kind of knowing, we have a rational kind of basis for thinking, all right, results have looked this way in the past, and they will continue to look something like this way in the future. It could be false that those regularities exist. Of course, induction can fail. But for the centered Born rule and these branch relative laws, they're not providing any further reason to think that induction will succeed, or any further grounds for our kind of ordinary rational practices in a way that the centered Everett interpretation alleges. So Isaac says that he wants these centered chances to provide some kind of rational constraints for rationalist decision theoretic approaches. And due to the inaccessibility of what branch one is in, which of these laws obtains, I don't think that it can do that sort of work. It's kind of my point there. I do agree though, this is a kind of issue that faces any kind of law we could have. It's not unique to the branch relative laws. I do think that the branch relative laws might be in a uniquely bad position given self-locating uncertainty, and given that they're supposed to play this role of giving us some kind of rational underpinning for other approaches to economic probability. But yeah, I do agree that perhaps no physical laws are really meaningfully accessible to us. Yeah, that's about all I have to say. Again, it's given me a lot more to think about. I wish I had better responses to some of these, but yeah, thank you for your comments. Really appreciate it.
Okay, questions? Start with Ray, and I've got everyone else.
Cool. Thanks. That was awesome. I am really curious about how critical it is that those any possible worlds are non-overlapping for CEI. So, in other words, is it the case that in order to adopt CEI, we have to be Wilsonian common little realists or something? And what happens to this view if worlds are actually overlapping?
Yeah. So after seeing your talk, this is something that I really want to think about. So why is it important that there's divergence rather than fission on the centered Everett interpretation? So I think part of it involves being able to kind of have a little bit more of a secure reference for these centered propositions. So if, for instance, prior to branching, there's two kind of overlapping worms that share a temporal part at T1. It's kind of impossible at T1 to say whether or not that stage or temporal part, what branch it inhabits, and so which law is true for that. So if you endorse the stage view, I do think you run into a problem there with having any kind of branch relative laws. Now, whether or not that turns out to be the case, if we have something like a worm view where worms share temporal parts, but it's worms at times rather than the temporal parts of worms that are making these propositions and that these laws apply to, I'm not entirely sure. That's something that I'm still kind of thinking about for another paper. Yeah, I don't know. And in fact, I had never really thought that much about the divergence picture. I always imagined Everettian branching as this kind of fission rather than divergence up until I read this paper and some stuff by Al Wilson. So at first I was just surprised about the divergence picture as something different than, I guess, like genuine fission or branching. So yeah, I'm still kind of thinking about that. But at least when you look at the stage kind of view where you're using temporal parts rather than overlapping worms, I do think there's a reason to prefer the fission view to that. Or sorry, the divergence view to that.
Chris?
Yeah, thanks for the talk. It's literally I'm very sympathetic to almost what you say. Here's just one question. So here's a worry I guess I have about both of you, and I'm wondering whether this is one of your worries or whether it's like another worry and what your take on it is. So if we look at this from the perspective of a human, so like here's one of the pictures. You just have this mosaic. No agents, you have a mosaic, no branches, just a mosaic stuff. And then you try to write a simple and informed description of it. And sometimes because things are chaotic, but also sort of patterned, right? Chancy stuff ends up being one way of carrying certain kinds of information in this sort of simple and efficient way. So in that picture, like we're looking at description of the whole mosaic, so of course chances can apply to entire worlds. So let's say something says, okay, well actually maybe it's informative to have little sort of sub-indexing things. Maybe we'll have chances relative to this part of the mosaic. That's effectively what the branches are like, right? So we're going to tweak the best system account so we can have sort of, I guess, if things are informative enough, little sub-chances assigned to little chunks of the mosaic. I think that's an interesting proposal. But if we do that, what's the motivation for thinking, or what's the reason for thinking that it's going to be branches identified by the Everettian that are going to be the some things that get the frequencies? And there's tons of ways to carve things up. And there's branches, there's also branches of me, and branches of me in North America, and branches of, I don't know, all the rabbits born in China, and there's all sorts of things. And there'll be some interesting statistical stuff, odds are, all over the place. And so once you start going to this indexing move, then it seems like, I don't see why it wouldn't inevitably follow, like you start thinking, oh, there are good indexing chances all over the place. It's not just branches, but also too, the rabbits in China, or whatever.
Yeah.
So once given that you're putting it from a human perspective, what's the motivated reason for thinking, yeah, we should index branches, and that's it?
Yeah, good. No, that's an excellent question. So I think part of the motivation here, and this is something that, correct me if I'm misunderstanding you, but so an analogous kind of case might be thinking, all right, when I go to determine what the frequencies are in a particular branch, why am I concerned with maybe like the particular experiments that I perform rather than decoherence kind of events taking place all over, deflections that are unmeasured? Why are we so concerned with like these particular experiments that people are doing and like the worms that are in branches for particular like individuals and carving up the world that way, if the Humean mosaic on this view is something like describing all the activity of this very spread out, complicated wave function? Is that?
Well, I was thinking that, and if we go with Wallace, the branches aren't agent dependent.
Yeah.
But there's a relativity of how we carve. Like, there's maybe objective facts about this branching structure.
Right.
So it doesn't necessarily be agent dependent, but still, on how we decide to grade things, deciding to index chances to, hey, these little worm things, as opposed to, say, horizontal things or little patchwork batches of them, it's probably those seems totally unmotivated from the perspective of a human who's trying to hook the laws.
Yeah, so for me, I mean, the much more kind of intuitive way of thinking about what like the Born rule probabilities are is this more horizontal kind of picture of like what are the relative weights of branches or the relative weights in terms of like a superposition here, rather than these in-branch frequencies. As for why on the centered Everett interpretation it concerns these worms, I think it's just because the Born rule is this kind of thing, at least according to other Everettians usually and other people in quantum mechanics. The Born rule really is something about relating experimental frequencies to the amplitudes of wave functions. So we're going to pick out strings of experimental data as performed by agents and the reason that we're going to pick the ones in particular branches for the centered Everett interpretation is just this intuition of, I guess, something like a frequentist best systems analysis of what the chances are. I don't think that gives a good idea of what the chances are. So I'm in agreement with you there, but I think that it's just one way of like deciding what the chances really are. Is, well, frequencies along a single branch, because the frequencies are something that are relevant to people like us who do experiments and are worried about the Born rule. But why those should be the chances, I'm in agreement. I don't really, I don't agree with the standard Everett interpretation there. So I'm not sure if that's super helpful, but okay. I'd love to talk more about it. Thank you. Yeah, no, good stuff.
That is.
Yeah, thanks for that. Was there a very cool talk?
Oh, thank you.
Yeah, I have a question about the fundamentality of the Born rule. Well, I thought that it's even open to question if you have the standard view of, I mean, if you think of David Wallace's view as being standard. Because right, for some standards, that's the key observation that the multiverse is not fundamental and that all the branches talk is already non-fundamental. So if you think that only the universal quantum states and the Schrödinger equations are fundamental, and then everything else, when you start using the calls to fine-graning of the quantum universal state into branches, you already move to something that is less fundamental. So it would seem to imply that it cannot be possible for the Born rule to be absolutely fundamental because you're already at the derivative level.
Yeah.
So wouldn't it be an objection against thinking of the Born rule as being fundamental in the first place? I mean, the best thing to have is to have something less. You should use relative fundamentality, right? So could you say a bit more how you will think of relative fundamentality in this picture, or yeah?
Oh, okay, so you're saying, yeah, of course, the Born rule is already derivative on the more standard pictures. So why think that the standard Born rule is absolutely fundamental rather than we should start with relative fundamentality.
Yes.
Okay. Yeah. I'm just originally when I came up with this objection, I was just going up with the argument as written by Isaac Newton in his paper, where he says fundamental physical law.
Yes.
And I was immediately, my first thing was like, how could this be a fundamental physical law? I pushed him a little bit on it, and basically what he said was, yeah, you're right. Like, I don't think, I didn't have anything specific in mind when I said fundamental. So I almost feel weird including this argument still, but it was in the paper that I submitted here, and I didn't find this out until later. And so I thought, I should include it. But yeah, with that caveat. So why not think of it as relatively fundamental? I'm just not sure. Like, what work would that be doing? So yeah, sure, call it relatively fundamental. Is it just everybody's happy now?
I don't know.
Yeah.
I got you with objection 5.
Yeah, and I still don't really understand the motivation for taking it to be fundamental in the first place. And that was kind of why I'm like, why even say that it's fundamental? I don't see what work it's doing. The one thought I have here is coming from Ryan's objection. One of Ryan's comments actually clarified it in a way that I had thought about before, which is something like, as far as explanatory fundamentality goes, maybe you were getting something new at the centered level, something kind of about these emergent but objective chances that can't be explained by the uncentered facts. So if anything, I think it's probably more accurate to say that there's a case to be made that it's explanatorily fundamental rather than ontologically fundamental. If it's relatively ontologically fundamental, yeah, I don't. It's already not as relatively fundamental as the Born rule, which the Born rule is not a particularly fundamental thing, and perhaps you might think that Everettian quantum mechanics also isn't a fundamental physical theory. So yeah, I think the argument that this is ontologically fundamental it's probably not going to go through. If anything, it's maybe explanatorily fundamental. Yeah, thank you.
Yeah, thanks for the talk. I think my question is related to some things you already said. Maybe you can help me clarify some things. But I was thinking another problem, and not for you, but I guess maybe for Isaac's view, or maybe even for many words. I don't know. You will tell me. It's like I'm just confused about the evidence. So there are like 1,000 of you or 1,000,000 or infinite of you right out there, right? And you're looking at some evidence, say in an experiment for a standard life thing. And then you see one of you sees, well, many of you actually sit down.
Many of you sit down.
Many of you sit down, right? But I'm just confused, like, so the same outputs, like, might count as evidence in favor of one thing and against that same, like, because, right, you know what I mean? Like, there are many of you and you are going to eventually be in different branches, and so it's just very hard for me to just think of how scientists actually discover laws, right? This is related to what you were saying. You collect some evidence and then you think, okay, maybe this is what is explaining the data. And here, many of you are looking at the same evidence and making inferences that might go in opposite directions. And it becomes messy, and I don't know how you ever find the one rule to begin with. And I don't know, I get confused about the evidence for this.
So I have this other paper that actually I wrote before this one where I kind of talk a bit, I think, about that.
Okay.
And so the idea is, well, yeah, you have some set of evidence you observe, but certainly the evidence is going to be branch relative. How do we essentially know whether or not you are a person in an atypical branch where the Born rule is actually true across all of the worlds, but you're in like a kind of atypical one where the results don't seem to align with the Born rule, versus thinking, no, many worlds is just false, and the Born rule isn't describing the right probabilities, and I'm observing the correct objective frequencies, right? Yeah, so that's, I think it's a very good question. A lot of people have thought that, yeah, if many worlds is true, it does kind of undermine, maybe in some way, our relationship between like scientific evidence and theory choice. So David Albert, in his 2015 book, kind of has this quote where he says something along the lines of, well, you know, if Everett is true, how can I ever be surprised by low probability experimental results? And what's the other thing? What? Something else. It's essentially a lot of what you're summing up. And I think the decision theoretic kind of approaches have some kind of answer there, which is, well, you need to basically use Bayesian thinking and condition the probability that you observe these kinds of results, given that many worlds or quantum mechanics in general is true, on the idea that something else might be true, right? And then it seems like, well, we might have these kind of other more Bayesian or decision theoretic reasons to think that the evidence supports many worlds or quantum mechanics in general when you see Born rule conforming results. But you can't really get it, I think, from the Decentering the Everett interpretation, which is kind of, yeah, my point with this last objection is it's like, in order to be able to make those kinds of inductive inferences, I think you already need to have something else other than these branch models. Yeah, cool, thank you.
Okay, we've got 2 minutes. Last question to you, Jane.
Oh, funny enough, I was gonna ask the question about that. So I could ask you a separate question. Like, there was a question about you were talking about the relationship between like frequencies and subjective like experiences. Maybe.
Yeah.
That would be helpful. Sorry.
Was it? Do you remember which?
The one we talked about, like Isaac's view, like you were worrying that the connection between frequencies and subjective, or like self-locating uncertainties on there or something like that.
Okay.
But in any case, like the basic status of chances, I was just wondering whether they could use something like an inverse principle where they say, well, along this branch, I mean, I don't endorse it, but like I don't, on this branch, whatever makes me have certain constraint my degrees of beliefs are the chances, so kind of like flip it around, flip the principle around, so that those can be the chances of that branches. And then you're worrying that they might come apart from the self-locating uncertainty of the branch and so on.
Oh, sorry, could you repeat it one more time?
Oh,
so the inverse principle would say what in this?
Oh, it will say, instead of saying that my degrees of belief ought to be whatever the chances are, you say the chances are whatever my degrees of belief ought to be, and it ought to be being in some kind of like maybe some locating uncertainty kind of way or some other way, so that you get chances in branch.
Okay, you get the chances in branch, but the chances, what's giving the chances aren't the frequencies, but are the gradiences.
Yeah.
Yeah, I think, I mean, that to me sounds a lot closer to like the self-locating or rationalist approaches to born rule probabilities that other people have proposed. But this is supposed to kind of be an alternative to that.
On top of constraint to the.
Yeah. Yeah, I think this is supposed to be like exactly the opposite of it.
Yeah.
And that's closer to the approach that maybe like, Chip Sevens and Sean Carroll, et cetera, have, where self-locating is going to work. And I think that maybe that is more intuitive, given that, yeah.
Okay, well, thank you, Jerome.